Hey ladies and gentlemen, all right, this is the video for rule number 1 of reducing radicals. Now the question is, why are we doing this? Why are we learning this? Because guys, there are going to be times when we are going to ask you guys to put your answer in what we call reduced radical form. Okay, so what I'm going to do is I'm going to show you guys how to put your answers in reduced radical form. Now, what I'm going to do, you guys already have the key that shows all of these worked out, but I'm going to explain number 3. Okay, so as we look at number 3 right here and I explain it, okay, we're going to go through and we're going to look at, okay, the chart that I'm going to insert over here, okay, and that is the perfect squares table or the perfect squares chart. And what we're going to do is we're going to use those perfect squares to factor the real numbers right here. So I'm going to factor 40 and I'm going to look at those perfect squares. Now, when I look at that perfect squares chart, okay, I want to look for the square roots that will evenly divide into 40. So if we look up and down our perfect square root chart, okay, there is only one number in here that is going to evenly divide into 40, and that is 4. Okay, so underneath my radicand, I would do 4 times 10 because 4 times 10 is 40 because the square root of 4 evenly divides into 40. Okay, and then I write down x squared y. Okay, now we'll get to the variables here in just a second. Now, what we have on the key, it says that we take the square root of 4. Well, guys, we can take the square root of 4 and take it out of the radical, right? Because the square root of 4 is 2. All right, well, the square root of 10, that is not a perfect whole number. So we're going to leave that underneath the radical because there are no other perfect squares in our table that will evenly divide into 10. Now, x squared, that is a pair. So I can take out one pair of x's. So I take out, because the square root of x squared is x. That one is just over here. You guys have done that when you've done the Pythagorean theorem. Okay, you'd have something equals c squared. Well, you got to take the square root of both sides because the square root of x squared is just x. Okay, similar thing. And then y is just all by itself, so I keep it underneath the radical. And this ends up being your simplified. That is in reduced radical form. That is the simplified version. Okay, so that is rule number 1. You have no perfect square factors in the radicand. Now, I just explained what was on the notes key that you had. Now, let's go take a look and we'll work off one of the problems on your assignment. All right, guys, we're going to look at number 10. Okay, we're going to look at number 10 together on your assignment. And what we are going to do is we are going to simplify the square root of 1080. Now, when we simplify this, we're going to look at our square root table. By the way, this is on the back side of your notes. Okay, that's the rules of exponents reference. It's on the back side of that. Okay, I have this square root table. I am going to look for any of these square roots that will evenly divide into 1080. Well, right off the bat, what I'm going to do is I'm going to go to the very, very highest one, and I'm going to see, okay, will 225 go into 1080? Well, guys, to check that in your calculators, you can actually work it down, and you can do, okay, 1080 divided by 225. Nope, that gives me a decimal. So that is not a perfect square. Okay, so I would go down and I would check every single one of these. Now, it just so happens that, guys, I need to go all the way down here to 36 before I get a perfect square. Okay, so if you guys notice in my calculator here, if I take 1080 and divide it by 36, oh, that gives me 30. So that means that 36 times 30, those are my factors. Okay, so right here underneath my square root, I'm going to factor it. I have 36 times 30. I always put my perfect square first, okay? Because then what I can do is, well, the square root of 36 is 6. That right here comes out of the radicand, okay? And then the square root of 30. Well, now we need to double check, okay? The square root of 30. Do any of these numbers right here that are lower than 30, do they evenly divide into 30? 25 doesn't go into 30. 16 does not evenly divide into 30. 9 does not evenly divide into 30. Well, what about 4? Nope, 4 does not evenly divide into 30. 1 is the only one. So if that's it, then guys, guess what? The square root of 30 stays underneath the radical. That's as simplified as we can get it. And this right here is your answer in reduced radical form. Okay, now you're going to practice some others, but before you do that, guys, you need to go watch the video for rule number 2. We're going to talk about the second rule of reducing radicals. All right, see you guys there.